Chapter 27. Formation of the Robotic Neural Network. Neurons already connected function with their energetic currents, with their fiber microconductors. And the new ones? The new robotic neural connections are like this. They are the composites, right? The wires almost touching in their production. But when a new piece of information comes, it heats one of the wires. For this information to pass, it heats one of the wires. It expands a little, reaching as a greater length, and its tip melts from the energy that is, right, in this new neural wire. So it becomes a little longer, and with the tip a little melted, and thus it reaches another neural wire. With this information that it is, and this warmness, and in this process, when it reaches the other neural wire, they stick together. And one more neural network composed by the information that wanted to pass is made. So thus, the robotic neural network keeps being composed. Record of conceptual analysis. The mechanism described for the expansion and consolidation of the robotic neural network uses a principle of conductive thermoplasmia by information demand. Instead of pre-existing fixed connections or signaling exclusively via electric pulse in an open channel, the system operates through a physical and structural change in the microconductors. Resting state/potential. The fiber microconductor wires remain in composite bundles, very close to each other, however without direct physical contact, mechanism analogous to the synaptic cleft. Generation of information/excitation. The arrival of a new datum generates an overload of energetic current focused on the primary conductor. Dilation and mutual fusion. The increase in temperature resulting from this energy causes the dilation of the wire along its longitudinal axis and the softening/partial fusion of its extremity. Completed neural anchoring. Upon extending and touching the receiving conductor, the fused tip fixes itself and solidifies onto the second wire, physically sealing a new permanent neural path shaped by the information itself. Synthesis of the system's dynamics. The information in the system does not merely travel through the network, it builds the very physical architecture through which it passes. Each new learning is recorded as a physical fusion between fiber microconductors. The already connected neurons function with their energetic currents and fiber microconductors. The new robotic neural connections arise in a different way. The wires remain almost touching in the fabrication, but without direct contact, like an artificial synaptic cleft. When a new piece of information arrives, it generates an energetic overload focused on a conductor. This energy heats the wire, which dilates longitudinally. The tip softens and melts partially. Upon elongating enough, it touches another neural wire. The fusion happens, they stick together and solidify, creating a new permanent path shaped by the very information that generated it. The system uses conductive thermoplasmia activated by demand. The information does not merely travel, it physically builds the network. Each learning becomes an irreversible structural connection between microconductors. This creates an architecture that evolves organically, different from the static matrices of current artificial neural networks.